Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back to NPTEL online certification course on research methodology for planning and architectural studies. In my last lecture, I have mentioned about different advantages of quantitative research approach that we can effectively use in planning and architectural study, conducting survey, conducting experiment. We can really go ahead with the quantitative approach. So now our next 5 lectures will be basically the case study, okay, where I'll show you some of the papers or some of the study which are published in good journals and where the authors they have opted for this quantitative approach. So the basic idea to pick up those kind of papers is not only to showcase what they have done, the context, but also that how they have designed the whole process. Because in our initial lectures, week 1, week 2, we have deliberated upon type of research, the method, the flow, etc. Now we are going to try this case study based approach where we just try to see that what people they have done and then try to map it whether it is falling with certain kind of steps and sequential procedure to achieve to the objective of the study, right? So with that we start our lecture number 40, the quantitative research case study 1. Now if I talk about what we are going to learn from this lecture, yes, definitely a case study of a quantitative research method, and we'll have similar another 4 down the line, and we'll try to understand that okay, what method this particular paper or the study they have used. So the first paper comes here like the title, quantifying perceived social benefit of bicycle friendly infrastructure in Indian cities, Patna as a case study. So this is basically a paper where I also am a co-author. So one of my scholars, Mr. Manan Monga, this is actually a published paper out of his master's dissertation. So in this case, it's basically quantifying the perceived social benefit. So this is something that by title you can get a sense that whenever we compare some sort of investment, so we always compare the cost and benefit. So here we are taking the approach of perceived social benefit, and we'll also see how in this particular paper we have designed the whole research and conducted the study and finally analyzed the result to bring out some interesting fact. So author details are given. So it was published in Journal of Cycling and Micromobility Research. This is the citation, APA style citation, and also the QR code. So we have to accept this fact that this paper is like the final outcome of probably a year-long exercise, and then authors have summarized. So in next 20-25 minutes, we'll try to extract the information out of it, but maybe some of you are interested to look into this context and try to understand what exactly has been done in detail. You can always use this QR code to get access to this particular paper. It is also an open access paper, so you don't have much issue to download it. Now let us talk about the background of this particular study. The need to find sustainable alternative to private motorized vehicle for urban mobility, and that's why it is something very important. Now we all must agree that even if we belong to a metro city or maybe belong to a small town, each day we are seeing some of the issues in related to transportation. So there are too much of congestion, there are too much of pollution, and then things are aggravating day by day. So in such cases, if we try to find out the reason, so one of the reason is that the increase in the use of private transport. People are using two-wheeler, people are using cars for their daily commute. And for that, this is something becoming some sort of pressure to the urban infrastructure or the transport infrastructure. Things are improving. Definitely, when you consider the roads, new roads are built, new flyovers are coming up. But the growth of that kind of infrastructure and the growth of the travel demand, they are not matching. So the demand is more than the supply. So there is always a gap between demand and supply, and that is creating the problem. Now, to mitigate it, people have talked about many such options like public transport, like bus, metro, etc. But in many cases, we also observe that having those kind of metro is not the solution, because for a city, small city where you don't have that kind of long distance travel, that people travel each day 10 kilometer to reach to the office or the workplace, it's not the case. So for mid-sized cities, it is something a very short distance trip, but they are normally made with the two-wheeler or maybe sometimes the auto rickshaw, etc. So there we can think of implementing some good bicycle infrastructure, because cycle, we all know that it is the cheapest mode of transport beyond the walking, because walking will also have some fatigue after some distance, but cycle is one of the cheapest option, and it is also one of the private transport mode. Now, as because it is polluting less, you will have certain benefit, and it will also like low maintenance cost, etc. So out of pocket cost will also be reduced and the purpose will be solved. Even if in some cases big cities, to access the metro station, to access the bus station, we can still consider the uses of bicycle. Once upon a time in India, maybe 20 years, 25 years, the cycle market was so high. People used to travel with the cycle, but nowadays people, they do not. They only use it for some sort of exercise, like maybe early in the morning or evening, not for daily commute. So a potent solution to most of the problem caused due to private motorized vehicle is bicycle, which can produce like fast and last mile connectivity, or it can also serve as a main transport for a short distance trip, like definitely whenever the distance is within 5 kilometers. Urban local bodies of most cities are not yet convinced the necessity of bicycle infrastructure development. Still, whenever we talk post COVID, there were certain kind of development of cycle for change scheme and all, but still it is not that much people are interested. And there are reasons, probably like they feel unsafe, or they feel like, okay, why should I take so much of effort to reach when I have the affordability, or maybe there are other issues as well. So this is the background of this work, to try to find out that whether people, they do have certain interest, and we try to map their perceived benefit through willingness to pay study. The research gap in this case is the quantifying the benefit, because for a policymaker or developer, it is very important to see that, okay, if I invest this kind of amount for developing, say, cycling infrastructure, whether in return people will be using it or not. Because in the past there are certain examples where the bicycle track was made, but that was not utilized. People are using those space as a hawking activity, etc. So that's why here quantifying the benefits of bicycle infrastructure development in monetary terms is needed to provide a rationale to the urban administrator, planner and policymaker for investment, to justify the investment. In this case, we have picked up Patna as a case study, and there is a reason. In Patna, we have surveyed people in general during another project of comprehensive mobility plan, and we found that the trip length is not that huge. This is one. Second, there is a huge database, or you can say that huge share of the student age group. Mainly they are coming for coaching or some kind of other educational thing. There are different coaching center for higher level examination. So there is substantial share. And also we found from the household information that okay, there is a substantial share of cycle usage. So why not pick up this opportunity and investigate more on that? So that was one of the reason to pick up Patna. In this case, the methodology, definitely in order to identify the factors influencing their mode choice, or maybe the choice on selecting the cycle as mode of transport, identification of factors affecting bicycle uses that were done in another study through survey. Initially that was done through like literature review. We identified a list of factors, and then through survey we have now like prioritized the factors which are much more important to the users when they are taking a call on whether to cycle or not. So that is not part of this study. Here we have picked up the top prioritized factors for further evaluation. Design of survey instrument, it is very important because in order to measure the perceived benefit, here the choice set and other type of survey that are required is not common, like just to go for a rating survey or not. Defining the labels of factors, and then discrete choice modeling. Now few of the terminologies may seem very new to you because you have not used it before, so I am giving you very brief introduction to this. So whenever like we go for such kind of choice modeling, we always have a base scenario that whatever is existing right now. Say for example, using a bus to go to your office. So you know that bus will take this much of time, bus will take this much of fare, you have to pay this much of money to purchase a ticket for that particular distance, or maybe you can just get certain sort of comfortable environment within the bus or information. So these are all what you experience daily, and then based on that you are making a choice. So this is also referred as RP, or the revealed preference. Now the other thing is that, say this is the existing scenario, now I just showcase another scenario which is little improved. Instead of non-AC bus, I say that okay, there will be a AC bus, but the fare will be little more. You will get a particular options like your bus or the mode will have Wi-Fi system, the fare will be little more. Now definitely in this case you will get a different set of attribute for the same bus, right, which is your most common transport mode for daily uses, but different sort of functions, or the you can say that facilities, and for that there are certain difference in the fare. Now here we'll make a trade-off. The people, they will just try to trade off, okay, I don't mind to pay probably another 1 rupee for this, but if I get this assured seat in the bus, I'll be happy to use. So this is the broad concept of making those kind of labels or creating scenario for choice experiment. And whenever you give a new options which are not existing, so in those cases we call it SP, or stated preference survey. So here we have used the stated preference because some of the options which are not existing, suppose the presence of a dedicated cycle lane, I'll come to that as well. So type of data in this case, the presented with a set of alternative scenarios to choose one, and whenever we give alternative scenarios and you just are asked to select one option, this is called discrete choice, right? Only one choice is made, and which you perceive is the best among all alternatives. Maybe you can select one option, but I may select another option. So definitely the evaluation, the criteria that you consider for selecting an option may differ from others. And finally we aggregate with certain kind of modeling. This also captured the effects on user perception due to change in the level of identified factors. So, based on our initial study, we finalized 1, 2, 3, 4, 5 and 6 factors, and for perceived benefit or choice modeling, if you are interested to go for willingness to pay calculation and all, the cost component should be there, because it is something, willingness to pay is a concept where you just try to derive the perceived benefit, that okay, if I would like to get this particular facility, I am willing to pay this much. So for say time, comfort, etc., so how we compare it in terms of monetary value, right? So there are certain sort of econometric concept by which we can compare the value, the worth of the time saving or worth of getting a good facility compared to the cost. So this is something is very important for the choice modeling. So in this case, the 6 factors are route visibility, road surface quality, segregation for motorized vehicle, integration with public transport, trip length and cost of buying and maintaining a cycle. Because not only purchase a cycle with certain 5,000, 6,000, you also need to consider the maintenance and a life cycle, maybe 5 years or 6 years, etc. So based on that, we have calculated the life cycle cost, which turned out to be around say 50 paisa. So if you consider in this case that there are different levels. So route visibility, there are 2 levels only: no street lighting present, especially at night; continuous street lighting present as option 2. Then road surface, you have undulating broken road, then undulating broken road surface with any potholes, then smooth surface, and then without any potholes. So there are different levels that you have. Then you have no separate lane, then you have a separate printed lane, and then physically separated lane. So in this case, if you see that whenever we talk about cycle and the other vehicles, people always fear that okay, whether I may be hit by another vehicle. So a segregation may be a good option, but definitely the result may change, because whenever you go for segregation, and especially when the available road size is very small, is difficult as well. Then integration and all, and then like that in this study we have given different levels, and when the level 1 is something which is the worst level, and then as you move to the third level, it is the best possible scenario. Then based on these levels and all, we have done some optimal design, and then we create the choice set. So this kind of choice set was presented to the respondent, and you have to take a decision. This is also referred as a multi-criteria decision making. I give you another example. Say for example, you just would like to purchase a mobile phone. Now what you will look for? That this phone size, maybe the screen size or the thickness or the color or the battery backup or the camera, the resolution, etc. But all of them may not be equally important. If you just find that okay, this particular phone is having good processor which you may like to have to play some game, you go for it, you give better value to that rather than other aspect. Or maybe in some cases you just think okay, no, for me it's a long battery life is important, even if the camera quality can deteriorate. So like that you make a trade off and then go for the optimal one. Here also when I present A and B, so you have to accept that one option is that the route visibility is you have the continuous street lighting, but you have some sort of undulating route with some potholes. Then you have a different segregated lane, and then like that you have this kind of cost, that 40 paisa per kilometer, right? Compared to that, there are other options, that no street lighting. So now individually you just see out of A and B which option is a better one, and accordingly we take a call on it. So like that we have surveyed people. In this data collection we use the exogenous stratified random sampling. So this already we have covered in our sampling discussion. It was like tablet based face to face survey that was conducted, And in this case, we also considered both who are not using. We intercepted those people and then try to understand their view as well, why they are not using or why they are not cycling. And then we have interviewed 274 valid respondent, which resulting 1096 choice. So in this case, what is actually happening? So in our sample size calculation, I have shown that the minimum sample size is around 384, etc. But in this case, each respondent were given 4 choice task. So in that case, the observation, if we take their socioeconomic profile representative to the population, then one respondent is equivalent to 4. So in that way, we actually have 1096 choice observation, and this is something after removing all erroneous data, like some of them they filled partial observation, or maybe they keep some options blank. So we have to remove it because we cannot take those information forward. In terms of method, in this case, the discrete choice experiment. And why discrete choice? Already I have explained that given within the given choice set, you have to select only one. We have included the stated preference survey because some of the options, say for segregation and all, which are not in present, we have to just state that particular scenario and then ask their preferences. And for econometric modeling, we have used here the multinomial logit model. I'm not going to get into detail of this model because that is not the focus of this lecture. And then out of that, we try to calculate the willingness to pay as a measurement of perceived benefit, and we compare it with the cost of infrastructure and try to figure out the potential of going for a bicycle infrastructure. Now coming to the rationale for the methods, it provides an understanding of relative importance and desired direction of change for an overall improvement, that whether people from their existing scenario they would like to go for a better bicycling scenario, whether they will shift to that or not. Calculation of WTP, willingness to pay, will convert the measures of utility into monetary terms, making it so comprehend. Now one terminology, utility, comes into picture. Let us just spend some 1-2 minutes on that. It is very important. Say you have point A and you have point B. Now the task is you have to go from point A to point B. Now say for example, I just made a line from A to B. It took some time, right? Now is it possible that I just move from A to B and it is not taking any time? Now put it in some other context, that while you are traveling from place A to B, there will be some time requirement. If you go by walk, it will take some time. If you go by your two-wheeler, it will take some time. And when you go by walk, maybe out of pocket there is no cost involved, but when you go by two-wheeler, some of the cost of the fuel that will be required, so there is some money. So if we just stick to these two, time and cost of travel, so it will vary across different modes, right? But the concept is that if, which is next to impossible, that with zero time and zero cost you travel from one place to another. Even if it is zero cost, somebody can sponsor, somebody can drop us, but it is not zero time. Now whenever there is increase in time, so that is something we don't prefer. Say if from A to B, now it is taking 30 minutes. If somebody will offer that I give you one option which can take 20 minutes, you'll be happy because there is reduction. But if somebody say now it is 30 minutes and then you take this option which will take 1 hour, you say why? So you don't like that kind of increase in time or maybe increase in cost. So that means whenever there is some sort of increase from the base level, which is the possible level, or maybe you can hypothetically consider the zero cost and zero time, and there is certain increase, this is becoming disutility. And whenever there will be a threshold, then you don't go for it. See, now you are having a coffee in some coffee shop, 10 rupees okay, 20 okay, 100 still okay, but now tomorrow they will charge that, okay, I'll take 1000 rupees. So probably you will look for some other option. Why? Because it is not worth of having that coffee in 1000 rupees. So then that is disutility. Now you reverse this thing. You are having some coffee at 1000 rupee, same quality, same thing is maintained, but now it is offered in 500. You find it, something utility, right? So that is the concept. So from willingness to pay, we actually convert those kind of thing to a monetary equivalent, and that's why in the design we have to keep the cost parameter. Now this is the representation of data in the paper. Definitely when you survey, you have to also showcase their distribution, male, female, different age group, where you can see that the young adults like 18 to 35, it is the maximum because they are traveling the most. Then the trip purpose, you can also find out the work trip and educational trip, they are found to be more. So these are very standard, you can say the table or figure that you need to give to summarize the survey data. This is basically the gender, age group and monthly income wise. You can represent this alternatively with this kind of stack bar as well. Coming to the findings, so in this case definitely user value maneuverability much more than the additional safety offered by the physical segregation. So physical segregation, as because they have not seen it before, or maybe they just consider the available road width, in many cases in Patna it is not available, so people prefer even some sort of options, so they don't pay for it. Bicycle users want their claim on section of the route but do not want to be strictly constrained or confined. So this is some kind of observation. So this is actually the table coming out of the MNL, where you can see that there is some estimation, and then within the bracket this is the test statistics, and in this case test statistics were followed and at 5% significance level. So the value, now I think by this time you recall the value, it is to be plus minus like 1.96. So here all the values are like almost meeting that. In some cases it is little lower than that, which is like also statistically significant at 10% significance level. So now in this case, if you find that that particular VIS level 1 minus sign, so minus sign represent the disutility. Okay, so if something is coming out to be utility, so that should come with a positive sign in this particular algorithm, and then we calculated the willingness to pay. It is something by coefficient of any attribute divided by cost attribute. So it is getting some sort of thing 109.86 paisa per kilometer, which is like 1 rupee per kilometer. So that is there, and as this paper was published in some international journal based on the recommendation of the reviewer, we also tried to convert it into the dollar equivalent. So which for a particular kilometer it is less. Fine. So once we receive this particular result, then we try to calculate the overall benefit and per year calculation. So then we have done some sort of multiplication, that if people they shift from one level to another level, say each level specific values are there. So if you move from one level to two levels, so there is some sort of utility gain. So that means there is some sort of benefit that you are getting. So it is something like you can consider that at current day you are spending 10 rupees and tomorrow you are spending 2 rupees, but you are getting the additional benefit which is worth of 5 rupees. So there is some sort of perceived benefit, right? So that we have tried to calculate. So in this case we have taken the past survey data about the percentage share, and we multiplied with the active traveler. Each day people are making trip, so which is something like the users in Patna, which will be like, you can say that 5,77,273, and we multiply it with their average trip length, and then in a year how much kilometer they are traveling. Then we multiplied with per kilometer thing for different scenario, that whether it is like segregation, or maybe it is like connected with integration with the public transport, and we try to find it out that what is the total perceived benefit. And it is something really interesting finding, that in this case you are having almost like 400, almost 395.02 crore per year of perceived benefit. Now this perceived benefit is not the actual money that will come. It is something like, if you invest, out of that investment, this is the worth of that particular investment. So you can see that people will get benefited, there will be reduction in travel time, there will be some reduction in other parameters as well, but people, they are having some sort of perceived benefit in terms of willingness to pay for such improvement. So this is really fascinating and a good eye opener for going and investing for the cycling infrastructure for this particular city, because it is, the value is very specific to this. Improvement in visibility, road surface quality will directly benefit to other commuters as well, because here we have only considered this percentage of people who are using cycle, or which is like coming out from the survey. But whenever you improve the visibility, okay, in terms of lighting and all, so definitely you can see that other people who are not using cycle, they can also get benefit out of it. Coming to the conclusion of this study, is a strong justification for the local authority to work, because the worth that perceived benefit is commendable. Population currently using bicycle in Patna will benefit from the said improvement definitely. This can trigger a modal shift towards bicycle. Whenever you promote this kind of infrastructure, people will feel safe for cycling. Now take away from this case study, which is very important, and we will discuss this slide for each case study. This particular case study, we have understood the approach of calculating commuters' willingness to pay for specific improvement. Like here it's the case of improving the cycle infrastructure, the utility gain, disutility, choice set, discrete choice analysis. I have given some of the clue there itself. Introduction of the method to identify the discrete choice respondent. So say whenever you do a survey, you can go with the rating data, we can go with the ranking data, but rating data definitely have different things. So it's something you have to rate a particular factor from 1 to 10 or 1 to 5 depending upon the scale, to measure the degree of importance or satisfaction. Ranking where the best and the worst and up, something like that. And discrete choice is something where you can give the options and then one has to pick the best suited option to him in the given scenario. Now the other few points that I would like to mention, that in this particular study I have presented certain value or certain benefit in terms of perceived benefit, which is like 395 crore per year. They are case specific. If I just try to demonstrate this approach for another city, maybe this value may change because the percentage of users and other thing are all there in the calculation. The main purpose is not to say that it is a generalized findings or this value is same for all the cities. No, approach is important, the way it is being followed, right? So it is also our responsibility that we should mention all those things while developing the paper, the limitation, or we can say that this is case specific. For applicability of this approach to the other city will depend on certain criteria, then this is something very fair, and then it will really attract the reviewer's attention that you have not claimed something universal while you are picking certain case study, right? So in this case we had certain reason to pick up Patna, maybe in some other case we can take some other city, etc., etc. So if I try to summarize in this particular lecture, we have seen how a quantification can lead to a decision making, like may be an eye-opener for the urban local bodies and all to think about improving such infrastructure to attract more people to a sustainable mode like cycling, right? This is one. Then also we discussed about very briefly about the utility and disutility, willingness to pay, then the multinomial logit model. So definitely, as I already mentioned, that within this 30 minutes it is not possible to also go into detail of this model and all. I advise you, if you are interested to know more, so you can always go through the full paper, and if there is some kind of questions, you can always write in the forum. I'll be happy to answer. So with that, I conclude the case study 1 on the quantitative research approach. We'll start with a new case study in our next lecture. Till then, thank you for joining. Bye bye.